Hello and welcome to the screencast for the AP ECE Chemistry Chapter 7 Covalent Bonding Problem Set 2012. I'm Mr. Wilkosz. We are going to be drawing a whole heck of a lot of Lewis structures, so let's jump on right in. Okay, so the first question, number one, asks you to write and draw some Lewis structures. They give you a substance, carbon tetrachloride, CCl4. Your task is to figure out how many total electrons you have. So you look at the periodic table, find out that carbon, based on its placement on the periodic table, has 4 outside electrons, and each of chlorine has 7. The total up to 32. Place the least electronegative element in the center. That would be carbon. Usually it's also the thing that's written first in the chemical formula. And then place the carbons around it. Originally I started with just single bonds in there, and then I populated the rest of these chlorines with these dots to give them full octets. Followed a similar pattern with NCl5, got a total of 26 electrons, and started with N in the center, less electronegative than chlorine. Populated the 3 chlorines around, and then populated the electrons in the rest of the positions to fill octets for everything. Let's take a look at B and C, C and D. Okay, so for C, when you add up your total number of electrons, you have only 24. And this is the first one where you kind of like come up short. You don't have enough. If you try to just dot around like you did on the previous one, you actually don't have enough electrons. So we have to resort to putting a double bond in. It's best to have the double bond there with the oxygen, and there's a sufficient structure for COCl2. Take a look at D as well. SO3 2 minus works out in this way. The 2 minus adds extra 2 electrons, so the 2 minus gives you 2 more electrons, a total of 26 electrons. Let's take a look at the problem set number 9. Again, more and more and more Lewis structures. We are drawing. So we're following the same sort of pattern as the last one. In fact, for 9A, you are doing another one of Cl2, Cl, rewritten differently, but C still goes in the center, and you populate it around it. It's the exact same thing as 1C. Take a look at the answer to 9B. And there is 9C. Again, we're resorting to double bonds here. Alright, up next, 17, parts B and C. More and more Lewis structures, oh my. For PCl4 plus, first time we encounter a positive sign. Plus means you actually lose an electron, subtract an electron, so we have a total of 32 here. 32 electrons. Excuse me, make sure you put a positive sign for anything that has a charge here, and this is a good structure, PCl4 plus. BRF5 has an expanded octet. Count up, you get 42. So it'll even have an extra pair of electrons. Anytime you end up with extra electrons, it's different than coming up short, like when you need double bonds. Anytime you have extra electrons, add them to the central atom. Alright, let's move on to the next one. Let's look at problem 19. For problem 19, more Lewis structures, but now we're dealing with exceptions. So these ones are specifically like the weirdo things. We're dealing with exceptions. Your classic exceptions are boron is happy with 3 bonds or 6 electrons. Hydrogen is happy with 1 bond or 2 electrons. And beryllium is happy with 2 bonds or 4 electrons. Those are your exceptions. We see one of those in part A here. We see BF3 where it's got its only 3 bonds and 6 electrons. Hey, boron, nice job, way to be stable. And we have another one here where we have an odd number of electrons. That's a slightly different issue here, but this is the accepted Lewis structure for NO. So no, this is the right structure. Here it is.